Alright, so today we're working on the actual knife blade here. I have the two handles finished. I just did a short for the second handle instead of a whole other video because they're basically the same thing. So yeah, this is what we're going to be working on. I'm going to machine the main bevel in. I did a test run on one blade and it turned out pretty nice. I only on the test run I only did kind of that section there. On this one I'm doing a less of an angle so that I can keep the blade a little thicker, but it's still a compound angle, so it pivots down this way and it pivots towards the tip. And I did that so I could keep the blade thick enough because it's only 100 thou at its thickest. And then right here, there's a line and that measures about 73 thousandths of an inch. And it'll leave me room to sharpen it. So I'll be able to grind in a secondary bevel and then the primary edge. I think if you have three bevels like this, you'll have your first primary bevel and then a secondary bevel and then your third bevel, which is this main angle here. And I'm not sure what the actual angle is because you can kind of see it's a compound angle. So it's saying it's 2.1 degrees at this angle right there. If you can, I guess you can probably see that. So anyways, this is the operations over here. We're just gonna do a facing the stock I have is 160 thou and it's just 1095 steel, but it's very hard and with the carbide cutters it machines just fine. I didn't have any problem doing the last couple of them. I think the only issue we might run into is later on. I'll show you. So first cut is just facing. Second pass, and this is where we might run into an issue. So I do have a couple passes. I'm not doing this all in one pass. It's just gonna try it with just a 3mm end mill. And it's gonna do two step downs. The first one, it's not a whole lot. It's like 10 thousandths per step down, which is still kind of a lot for a little ball end mill. And I have ball end mills in 3mm, 4, 5, 6, all the way up to 8mm. Actually, I think I have some like 1/2 inch ones too. But I'm thinking 3mm is probably gonna be the best. So yeah, I guess we'll see when we get there how it does, and I can compensate by just slowing it down or whatever we need to do. So then we're gonna flip the blade over, and I'm just gonna pre-drill this one hole and then pre-drill these 3 holes. And if I were better at this, I could probably figure out a way to make it do 2 passes, but what I had to do was a tiny little radius just so that it would fit inside of here, and I didn't want to break it into 2 separate operations because that would have taken like 10 seconds, but here we are. But these are mostly pre-drilled to almost final size, so it shouldn't really matter. This will basically, instead of it thinking it's a pass, it'll just be a plunge, and then it'll spiral all the way down. The main issue is the end mill is really close to this hole size, which now that I'm looking at it, it doesn't look like it's even gonna work. Oh no, there it is. Yeah, there's a spiral. So I did give a warning because it's only gonna do 1 pass where I requested that it do 2 passes, but because the end mill is just barely smaller than the hole size, it's only gonna do 1 pass down, and then you can see the final pass where it goes out like 4 thousandths of an inch or something. I get the holes all done. just so I know that it's gonna be on a flat surface that the hole's drilling into. I like how they simulate a glare. That's funny. All right, so we'll do another facing pass, and this is 2 passes, about 15 or 20 thousandth depth. Next is the same thing we did on the other side, and you'll notice I did make sure that I started both of them at the low end, so they'll have to plunge deeper to start, but that way, as it steps over, there won't be any problems with backlash in the Z-axis. I got most of it taken care of with the double ball nuts, but there is still some, which, I mean, next step would be high-end ball nuts. I think there's just a lot of weight on that head, and Chinese ball screws, ball nuts just can't hang. So if anybody knows of some high-end 20 millimeter size ball screws that they want to get rid of, I would be in the market. I'm not gonna go out and spend $300 or $400 per axis. But anyways, we'll get this done. I made sure that there was only 1 plunge and 1 retract, just so there's no issues with backlash. Last step is gonna be this contour, and it's gonna ramp all the way down, and it's gonna leave about 10 or 20 thousandths of an inch to come back and clean up. And I'm gonna leave tabs, so these tabs are all manually set in. Fusion has a manual tab setting deal where you just click where you want them to be. So after it's all done, I'll have to go in and cut these and then grind them down flush, which isn't a big deal at all. It'll be fine. All right, so we've got everything set up in the mill here. I'm gonna get the, we're gonna find our edges, and then we'll get started on the machining. So I'm doing the same thing here where I'm gonna find my edges off of this back corner. Then when I flip it, I'm gonna find them off of the front corner, which will be the same back corner. Just in case there's any variation in the actual width versus what I have programmed into Fusion for the cam. So you just watch for that thing to kick off to the side right there. And that tells us we're exactly 100 thousandths of an inch off of the edge of this part from the center of the spindle. That's because this little tip is 200 thousandths of an inch. So we'll find our edges here. Almost there. Okay. There's our Y0. Alright, we're right on the edge. So I'm going to take the drill chuck out and get an end mill in, and then we'll touch off, and that's where we'll get our Z0. So I'll bring you back when we get there. So for the still, last time I used a 6 millimeter, just a 4 flute carbide end mill. This time around, I'm going to use a 1/4 inch 5 flute end mill. It works a little bit better in steel, I think. Alright, so we're going to touch off on our Z. I usually just come kind of somewhere near the middle of the part. Just bring the tool down pretty close, and then I use the mouse and the incremental step to get it the rest of the way down. And you just go until it catches the paper, which is right there. And that'll tell us that we're about 4 thousandths, well, 3 or 4 thousandths of an inch above the part there. And we're gonna go ahead and start it up. Now I have some cutting fluid here. I usually do a concoction of this stuff, which is just thread cutting oil. And then I'll usually squirt a little bit of brake fluid on it to thin it out a little, because this stuff is super thick. Not a big fan of whatever, I think just high sulfur cutting fluid. But this is gonna be a facing operation. And I've had pretty good luck with just squirting a little bit of brake fluid onto the cutting fluid. It's weird, but it works pretty well. It helps the fluid get everywhere it needs to go. Otherwise, it just kind of gums up and all the chips stick to it. All right, let's see how we do. It should be, I think it's a ramp. Well, maybe not. Can't tell if it's ramping down. Maybe it's not. I think it might just be 2 passes. Probably speed this up since this is going to be a first pass. There'll be a second pass, and maybe I'll slow it down for that one. Didn't like that. Does not like plunging, which is why I usually do a ramping. So we do get a very nice finish on there. You can not even feel really anything, which means I have it trammed in pretty well. I just wish I had a higher spindle speed. We'll have to work on that here pretty soon. That took, I don't know, like 5 or 6 minutes to just do 2 passes, which is kind of a long time. But I mean, if you're me, you don't really have anything else better going on a Saturday, so here we are. All right, so this operation is gonna be where a high-speed spindle would really, really help, because I'm gonna be machining the entire bevel of the blade with this little 3mm end mill, and you just have to go really slow to get any sort of nice surface finish. And I only have 1 3mm end mill, so gotta be very sure not to break it. I'm gonna use a little more cutting fluid on this go around. And a little bit of dish. Let's see how she does. Just gonna go really slow as it plunges in there. Looks like we're 40 thousandths. Well, no, we're 40 thou from the top of the stock, and we took off 28 thou. So this is only about a 13 thousandth or 12 thousandths pass. Should be fine. Uh-oh. Something happened, the x-axis is not going now. That sucks, because now I lost my 0 on the X, Y, and Z. Dang it. That's a bummer. That used to happen a long time ago where the x-axis driver would alarm out, but I replaced it and it hasn't had a problem since. So here's my little, I don't know, CNC controller. Built it out of a little Home Depot toolbox. So I have the C11G CNC 4PC. That's the, I guess what you would call the breakout board. Then the Ethernet smooth stepper, which is this guy right here. And then underneath, I've got my transformers and resistors and all that stuff. And then X, Y, Z drivers, which it doesn't look like any of them are alarming. These little red lights will flash if there's an alarm, and they are not. So what the heck happened? Now I got my little fuses there. What in the world happened? That's weird. It's never done that before. Well, aside from when I first got it together, I just had a bad driver that would just alarm out sometimes. So I do have one flashy light there on the smooth stepper. I don't know what that means. Output status is good. So here's my outputs and here's my inputs. Oh yeah, so X, Y, Z. And I'm not getting any lights on my X. Little piece of schmoo on there, no? So that could be the dilemma, so hold you right above it. Here's my X-axis going in, no lights. Y and Z, I do have lights. So, oh man. It's been so long since I've done this, I don't really remember what all the lights mean, which is a bummer. I wonder if one of these fuses blew, because one of those is for the X-axis, but I think if one of these blew, the lights on the driver wouldn't be lighting up, because that's just power for the drivers, I'm pretty sure. Pretty sure the power goes through this, through the fuse, into those drivers there. And I've got X, Y, and Z. How's that guy looking? Looks fine. Oh, it looks broken. Actually, it's cracked. Shouldn't really matter, I don't think. And actually, I still have power to the driver. Alright, so I have the program stopped. And yeah, Z-axis is working fine. Y-axis working fine. It's just my X. Alright, I'm gonna replace that little fuse holder. I guess gosh, it sucks when stuff like that happens, especially if you can't figure out exactly why it happened. Because then, I mean, what if it just happens again? Hopefully I can find something wrong. I'll bring you back if I do. If not, I'll figure something else out. I think it's definitely in my best interest to figure out why it stopped working. So I'm gonna do that. All right, so I reset the Z driver, or the X driver, and now it works. I don't know why it did that. I'm gonna guess that the X driver is just going bad, which really sucks, because I mean, I already kind of have to babysit it, but now I really have to pay attention and make sure the X is moving when it's supposed to move, or we're going to end up with a bunch of scrap pieces. I guess this is a good time to upgrade from, I ordered them all from Steppers Online. They're supposed to be halfway decent. A ton of people use them. This is the second time I've had a problem, and it's both times been on the X-axis for whatever reason. But I'm gonna get my zeros figured back out again. We'll just fast forward through the program, and hopefully it picks back up right where it left off, as long as I can get the zeros right back where they were. I don't think I'll have a problem getting it within 1 or 2 thousandths of where it was, but just kind of sucks, you know. Alright, got all my X and Y and Z axis back where they need to be. Just gonna run it from the beginning and kind of just go through quickly. make sure everything's good. Looks like it, so I'll bring you back once we get back up to the point where we left off. Alright, so we made it past the point where it stopped last time. Just going super slow, make sure it's still good to go. Looks like it's working. Gosh, it's annoying though. Alright, we're almost done with our first pass. It's doing pretty well. The finish is freaking awesome. It's gonna look pretty sweet, I think. Hopefully it gets through the second pass okay. I think the second pass is gonna be a little bit of a heavier cut. I should have done it backwards. I don't remember which operation exactly I used. They all have different settings for feed rate and all that stuff, so I think I might have just split the two passes, which either way they're both pretty light cuts, but I should have done a little bit heavier cut for the initial roughing pass. But either way, I think the finish looks awesome, so it just takes a long time. Alright, looks like we're coming in for the second pass. Oh no! Why the heck is it dragging across the part? That's annoying. Hopefully it cuts all the way through. Hopefully. And then I think it'll cut all the way through that though. It should have lifted up and then started over, but it did not. So I'm just going super slow, but you can kind of get an idea. I've got it pretty well covered in brake cleaner and cutting fluid, but it's leaving an awesome finish. It's gonna make a way cool looking knife. This is the finished pass, so taking it really slow. Kind of see. That's where it dragged the tool across the part, but it's cutting below that. So shouldn't be able to see it once it's finished. I think it's gonna look rad. I'll bring you back when we're almost done. Alright, we're coming up on the final pass here. It looks really good. I switched over from a concoction of brake cleaner and cutting fluid to WD-40 mixed with cutting fluid. So those are just bubbles that you see down there. But the finish looks freaking awesome. I think it's gonna turn out super nice. Pretty excited about that. Couple more passes. I just went super slow and started getting the button for the knife set up in the lathe while this was running. And now it's almost done. Once this finishes up, we will flip the part over and we're going to do basically the exact same thing. I think there's a facing pass on the other side, and then we'll do the same. Alright, there it is. That's going to look pretty sweet once it's all finished up. Clear some of that off. Yeah, that's gonna be rad. And then I'll have the secondary bevel ground maybe 1/4 of an inch up, and then the primary at the very tip. That finish is super nice though. Alright, so the first step is going to be drilling a few holes. mainly just pre-drilling. So I've got everything set, all the X, Y, Z zeros. Yeah, should be good to go. Let's fire it up. And I just have it set to plunge. We're ready to go. We got the 200,000th drill bit. Just go a little faster than that. I think we're ready to start, so we're just going to do our facing and then the boring, moving right along. We'll just take this plunge real nice and easy. Still doesn't like it. Alright, here's our 3mm end mill. It's going to do the boring operations that we pre-drilled. Should go pretty good. It is spiraling down into that hole. It's just a tiny, tiny spiral because that hole is just barely bigger than 3mm. And it's an 1/8" hole. So that was the pre-bore, and now it'll go in and do a finish pass. Just should get a little lube on there so it should go all the way to the bottom, and then one finish pass. Alright, this side turned out pretty good too. Looks beautiful. That's such a good finish for these El Cheapo Amazon ball end mills. That's awesome. I was not expecting it to be that nice of a finish. So that where it's digging in like that, that's where it is going up over the tab and then dropping back down. This end mill just does not like to plunge. Yeah, it can handle going pretty fast. It's just those plunging it does not like. So now it's going up over the tab, and then it'll plunge back down. So I gotta slow it way down is when it starts plunging. Right there. Almost there. Alright, that's it. Let me clean it up, I'll bring it back. Alright, looks like we got all the way through. It's just paper thin. Yeah. I think though, I'm just gonna do a little bit of manual machining and take these tabs down a little ways. I don't really want to hacksaw through them, it'll take forever. That is quite a bit of metal left on them, so I'm just gonna try to knock those down, get them a little bit smaller, and I'll bring you back. Alright, I just knocked all those tabs down a little bit. She's getting pretty loosey-goosey now. Let me clean it up a little. Not much holding it. Let's see here. So, zoom me out. Looks like a knife blade. Almost. I think it's gonna be so sweet. That's pretty cool. Just a little bit of grinding work. Still got plenty of meat there to cut my other bevels in. Yeah, I'll bring you back once I get it all cut out. All right, here it is, all cleaned up. I think it's gonna be rad. I'm gonna leave the milling machine or the machining marks in there. I'll just grind a nice bevel. Yeah, where's the handle? You grab the handle, I'll show you all together. Alright, so here's how it's gonna go. Like a so. I think it's gonna be pretty nice. We'll anodize it. Just gotta make the button and the pivot pin and then a little bit of hand fitting and we'll be golden. Pretty cool though. Turned out way nice. Alright, thanks for watching. See y'all next time.